Okay, welcome back to 3.7 notes, and this is the chain rule. And what we're trying to do is we're trying to find the derivatives of these functions. And so what I want to do here is I want to find the derivative of this function. Now, the first thing I'm going to do is I'm going to do y equals 5 times the quantity cosine of x to the fourth, okay? Or I'm sorry, to the negative fourth. And so what I want to show you guys is that, you know, if you were going to do this, you may sit there and you have to go, okay, well, I'm going to have to put this back into y equals 5 over the quantity cosine of x to the fourth in order to find this derivative, and you don't have to. We don't have a rule for this per se, but we can use the chain rule. And what you need to see is you need to see that you have an outside function, okay, 5 times some quantity to the negative fourth, and then you have an inside function cosine of x, okay? You can still do it this way and using the quotient rule, but I think the power rule is a little bit easier. So I'm going to go ahead and use the power rule. And so let's see what we can do here. Now, here's what I've got. Here's my inside function, and I'm going to call this u, all right? So if I let u equal cosine of x, then what I want to do is I want to come back here, and I want to I'm going to rewrite my function as y equals 5 times some quantity to the negative fourth, and I'm going to put my u in there, okay? All right? So now what I want to do is I want to take the derivative with respect to x. So if I take the derivative with respect to x, then I get dy dx, okay, is equal to, and I'm going to do this. I'm going to do drop down the negative 4 times 5 gives me negative 20, and then we subtract 1 so we get to the negative fifth. But because when I take my derivative with respect to x, my variable in here is not x, it's u, okay? And u is a function. So I leave my inside function, but then I have to multiply by the derivative of my inside function, okay? So up here I need to find u prime, okay? And so u prime, the derivative of cosine, is negative sine of x, okay? So I have my u prime. Now I need to come back and chain it all back together. So I'm going to write my derivative like so. I'm going to write it as dy dx is equal to negative 20 times cosine of x to the negative fifth, and then times negative sine of x. Okay. Now what I can do, you know, you can leave it like this if you want. If you want to simplify it and write it like dy dx is equal to positive 20 times cosine of x to the negative fifth, and then times sine of x, that works too. Okay, that's a multiplication symbol. And so if you want to, you know, clean up your negative signs and all that, that kind of works. So sometimes the simplification on these is a little bit easier. Sometimes it's a lot harder. So let's go ahead and move on to the next one. This is number 22. Okay, so this one's kind of interesting, okay? What I see here is that my outside function is some e to some power, okay? So what I want to do is I see this inside portion here, and I'm going to let that be my u. So I'm going to let u equal 4 times the square root of x plus x squared. Okay, so when I come back here, I'm going to rewrite y, and I'm going to say y is equal to e to the u. Okay, so now what I've got is I want to take my derivative with respect to x. Okay, so I'm going to ddx the whole thing. And so when I take my derivative with respect to x, I end up getting dy dx is equal to, and then I'm going to get e to the u. The derivative of e to the u is just e to the u, but then because the x and the u don't match, okay, because I'm using the chain rule, because I have an inside function, I have to multiply by the derivative of my inside function, so multiply by u prime. So then if I wanted to calculate u prime, I can do that over here, and I get 4 over 1 times 1 over 2 square root of x, and then plus 2x, okay? And so I can simplify this a little bit, and let me, the 4 and the 2 divide out to 2 over 1. So I get 2 over the square root of x, and then plus 2x, okay? So I have my u prime, okay? And I have my u, and I want to resubstitute these back in and then chain it all back together, hence the name, the chain rule. So let's go ahead and do that, and I end up getting dy dx is equal to e to the u, and the u was 4 square root of x plus x squared, and then I'm going to multiply that by the quantity 2 over the square root of x plus 2x. Okay, this is unsimplified, but we're just going to go ahead and leave it like this for now. All right, so sometimes it requires us to simplify, but for these videos, I'm not going to simplify. Okay, let's go ahead and move on to the next one. And what I see here, and we've done one similar to this from the old homework. I'm going to go ahead and skip that one. I'll let you guys do that one on your own. Aha, this is the one I want to do. Okay, so what I see here is I see some function g of t, okay? And that's this whole thing raised to the negative 1, all right? And so what I want to do is I want to identify my outside function, some quantity raised to a power, and then I have an inside function, okay? And my inside function is what's inside my parentheses, and it's this whole thing. So I want to let u equal 1 plus sine of 3t, and that's going to be over 3 minus 2t, okay? So what I want to do here is I want to come back and I want to write g of t is equal to the quantity, some quantity to the negative 1, but it's some inside function u raised to the negative 1, okay? So what I can do here is I can take my derivative and I get g prime of t, and because I have an inside function that's over here, I'm doing the chain rule. I'm going to drop down the negative 1, multiply that by my function, raise it to the negative 2. Okay, we keep our inside function at u, but then we need to multiply by u prime. Okay, so now we got to find the derivative of u over here. We've got to find u prime, and this is a little bit easier said than done because I'm noticing a few things about this. All right, in order to find u prime, I have to use the quotient rule. Okay. So I have a high function, okay? I have a high function, and that high function is 1 plus sine of 3t, and I have a low function, and that function is 3 minus 2t, okay? Now, here's the deal. If I were to find d high, I have another inside function here, okay? I have this as my, I'm going to call this another inside function, and this I'm going to call w. Okay? So my high function, okay, I'm going to rewrite my high function as 1 plus sine of w. And so if I wanted to take the derivative of this, if I wanted to find d high, okay, and the derivative of 1 is 0. The derivative of sine is cosine, and this is w, so I have to do another chain rule, so w and then times w prime. Well, w prime is just equal to 3. All right, so my d high is 3 times cosine of w. W is 3t. Okay, so I do have to do chain rule if I don't have a rule. We don't have a rule for sine of 3t. If it's anything other than just a t or a variable, then I have to use the chain rule here, okay? So now let's go ahead and do the derivative of low. Let's do d low. And so we end up just getting negative 2. All right. So now, if I wanted to find u prime, okay, I've got to do low d high. So I've got the quantity 3 minus 2t times the quantity 3 times cosine of 3t, okay, minus the high function, so minus 1 plus sine of 3t, times the derivative of low, which is negative 2. Let me get another parenthesis here, negative 2. All right, and then this is all over low squared. So the quantity 3 minus 2t, quantity squared. All right, so now I have a u, I have u prime, so let's write our function over here, the derivative of g. Okay, and I know there's a lot going on here, guys, but we've got to practice this. The more practice you do, the better you get. And once you do enough, it's pretty much second nature. So then you get this. You get negative 1 times the quantity u. Okay, I'm going to plug u back in. So instead of writing u, I'm going to write 1 plus sine of 3t over 3 minus 2t. Okay, I'm going to raise that whole function to the negative 2, and then I'm going to multiply by u prime. So then u prime is this whole thing, all right, 3 minus 2t times 3 cosine of 3t, and then minus the quantity 1 plus sine of 3t, and then that whole thing times negative 2, and then this is all over 3 minus 2t, that whole quantity squared, and quantity. So this is your derivative. Okay, I mean, this is tough. This is not easy, but it's all about just the chain rule. Okay, and you being able to identify when you have inside functions and when you have outside functions. Okay, so let's go ahead and do another one. Okay, let's do this one, cotangent of the quantity sine of t over t. So here's what I've got. I have an inside function here, guys. Okay, here's my first u. All right, so I'm going to rewrite write u over here. So u is equal to sine of t over t. Okay, and so once I'm going to come back over here and I'm going to rewrite this as q is equal to cotangent of u. All right. And so what I want to do is, if I wanted to find q prime, all right, because I had to change up my variables in terms of t, but now my variables in terms of u, if I'm taking the derivative with respect to t of some function with u, then I'm going to get negative cosecant squared of u, and then times u prime. So let me make sure I rewrite those with blue. So u, and then u prime. Okay, so I need to find u prime over here. So this is in order to find the derivative here, I've got to use the quotient rule. So I've got a high function, which is sine of t, and I have a low function, which is just t. So d high is equal to cosine of t, and then d low is equal to 1. So then u prime is equal to low d high, so t times cosine of t, all right, minus the high, which is sine of t, times the derivative of the low, which is just 1, all over t squared. Okay, so as I'm rewriting this, okay, I'm just going to chain it all back together. I've got my u, I've got my u prime. So I come back over here and I write that q prime is equal to negative cosecant squared of u, which is sine of t over t. Okay, and then multiply that by my u prime, so by this whole thing over here. So I've got t times cosine of t minus sine of t all over t squared. Okay, so this is my derivative for q prime. All right. All right, I'm going to do 52 real quick, and then we'll take a break, and we'll do 58. I think that's it. Okay, now we got a couple more. All right, so 52. All right, let's take a look at that one. I've got y equals secant squared of pi t. Now let's rewrite this so it's a little bit better. okay? So we've got y equals the quantity secant of pi t, hold on, of pi times t, that whole quantity squared. Now, here's what I've got. Guys, I've got multiple inside functions, okay? I've got secant of pi t inside of this big one, this quantity squared, and then I have the inside function pi times t. So what I need to do is I need to identify what those are. So my first one, I'm going to call this my u. Okay, so I'm going to let u equal secant of pi t. Okay, and so I'm going to rewrite my y as y equals the quantity u squared. Okay, so I'm going to write, let me get the squared in there. And then this is my u, okay? And so if I wanted to find y prime, then I get y prime is equal to 2 times u to the first times u prime. So let me write that in there with blue. So 2u times u prime. Okay, so now I need to find u prime here, but I've got a problem. I have an inside function inside of my secant function, and that's pi times t. So I'm going to do another substitution here. I'm going to do another chain rule, okay? And I'm going to call this w. So w is equal to pi times t, all right? So now I'm going to rewrite my u function. So u is now equal to secant of w, okay? And so now what I want to do is I can find u prime. So u prime, the derivative of secant, is secant of w times tangent of w times w prime. Okay, so now I know what w is, but I've got to multiply by the derivative of this inside function. So what I'm going to do here is I need to find a w prime, and my w prime here is just going to be pi. Pi. Okay, so if I rewrite this u in terms of t now, I get u prime is equal to secant of pi t times tangent of pi t times pi. Pi. Okay, so now I had to chain the w and the w prime back into here. Now I got to chain the u and the u prime back into my original one. Okay, so now here's what I've got. All right, I end up getting y prime is equal to 2 times u. Well, u is just secant of pi t. So secant of pi times t, that to the first, and then multiply that by u prime. So that's secant of pi t, and then times tangent of pi times t, and then times pi. Okay? And that's it. That's all I need to do. So this is my derivative. Okay? Much simpler than what we had. All right? I'm going to go ahead and stop this video, and sorry it's kind of long, but hopefully this helps. Thanks.